This is Project Smile, and the circuit itself is basically made up of some LEDs that shows a little bit of a picture. So this would be an eye, a nose, and this is the mouth. Okay, so a very simple idea, but it's Project Smile. So the basic concept of the circuit itself is you have your, of course, battery, you have a power supply here, which is a 5 volt and a 3.3 volt, and we have relays that are built for 3.3 volts control. This is a main relay that powers this power supply, and then each one of these sections, like for instance the eye is section 1, this eye over here is section 2, and 3 and 4 the nose and the mouth. Basically what's happening is these relays, we'll talk about later on when we do the actual demonstration, control the voltage going to each one of those LEDs. So for instance, the concept we're looking for in this case with these relays is a built-in self-test where it actually toggles the power for each one of those independent circuits one at a time, and allows us to look at the test results so we can see if you basically induce a fault, will your system pick up that fault. Then the bits themselves is a separate part of the circuit where these optocouplers will sense that that circuit is on and produce a 3.2 volt high if the circuit is detected as being on, and of course 0 volts if it's not. And that 1 and 0 are your logic bits that go over to the FPGA, and the FPGA's algorithms are built in to detect each one of those sections depending on if the bit is high or low. And we have indicating lights over here that you'll see when we turn the power on. And this is a simple clock circuit that you see blinking, so if it bothers you, it's okay. And where the bits are coming in is right here. The power to the main relay is here. And over here is for the actual built-in self-test where it toggles the relays that power those independent circuits. And this part right here is just the other part of it. So there's 4 circuits all together. This is for section 1, section 2, section 3, section 4, and the numbers correspond to the actual breadboard. In a quick demonstration, this is the main bits. So this shows that I'm looking at my bits as the first light, and then section 1, 2, 3, and 4 are these green lights. So it detects that those things, each one of those circuits have a good bit. So the built-in test shows that they're all good. Just to show you, we have manual overrides. So this would be section 2, and if I break the circuit, my circuit detects that it's broken. If I obviously fix it, it's back there. So that's just a manual override just to show that the circuit works. This is the built-in self-test where it automatically cycles through each one of those. And we'll try to capture the individual lights. These red lights show that the relay is closed, and it provides the current or the path for current for each one of those sections. When the red light is off, it means it's open. Now we're going to go through the bit sequence. So the corresponding lights show you 1 and 3. 1 and 3 are on, 2 is on, 2 is on there, and also on the FPGA has its own indications that correspond to those proper bits. And that's the end of the built-in self-test, and we can turn it off and everything goes back to normal. That's it.